students, I hope your preparation is going good. If not, don't worry. Sri Gurukula is here to help you. And I am Anmol Yadav. I will be your physics and mathematics mentor. I am an NIT-JEE graduate. So bring out your books. Let's make your preparation stress-free. So today I am back with another video on motion in a plane. And today we will be discussing projectile motion, that is horizontal projectile and projectile at an angle theta. So without any further delay, let's start our today's lecture. So today we will discuss about projectile motion and we will solve some PYQs as well. Let's start with projectile motion. That is projectile at an angle theta. So this is our ground and we are giving an object velocity u at an angle theta. So what path it will take? It will take a parabolic path which we call as a projectile motion. Correct? So this is the parabolic path, which is the path of projectile motion. Now, what we'll do in motion in a plane, last lecture, what I said, how we will study this motion in 2 dimension. What we'll do, we'll divide everything in motion in 1 dimension. Like we'll divide every component in x component, y component, and then we'll apply all the equations in x direction, y direction, and finally we will find the resultant to solve our questions. So similarly, what we'll do, we'll first do the components. So this is u at an angle theta. Means velocity in x direction will be u cos theta and velocity in y direction will be u sin theta. Correct? So velocity, initial velocity in x direction is equals to u cos theta and initial velocity in y direction is equals to u sin theta. Acceleration in x direction. See, this is the earth. There is no acceleration in x direction. So acceleration in x direction 0. Acceleration in y direction. So this is the earth. Earth is always applying a constant gravitational acceleration which is 9.8 or also known as small g. And in which direction? Negative direction. So acceleration in y direction is negative g. Correct? Why negative g? Because we are considering this direction as a positive direction. And acceleration due to gravity acts in the opposite direction. That's why there is a negative sign. Now, everything we have, now we can apply all those 3 formulas in motion in a straight line. So first what we'll do, let's study in x direction. In x direction, final velocity in x direction, v is equals to u plus at. So final velocity in x direction will be equals to initial velocity in x direction plus acceleration in x direction into t. What is acceleration in x direction? It is 0, means this will be 0. So final velocity in x direction is equals to initial velocity which is u cos theta. And see, and if you will see, we are giving initial velocity at an angle theta. So for a particular projectile, this thing will not change. Means final velocity in x direction will remain constant. This is constant for particular projectile. So if we are changing velocity and theta, then it will change, or else it will remain constant. It means at any point, if you will find the velocity, for example, here as we will be having some velocity and you will do some components. Let's suppose this is v, vx and vy. So at any point, if you will find x component, you will find the same value which is u cos theta. This will also be equals to u cos theta. No matter which point, at this point as well, velocity in this direction will be u cos theta. At the final point again, if you will calculate velocity in x direction, it will be u cos theta. Understood? So velocity in x direction does not depend upon time; it only depends upon the initial value and theta. And for a particular projectile, it will remain constant. Now another formula we can apply, which is displacement in x direction is equals to uxt plus half ax t square. Again, formula from motion in a straight line, s is equals to ut plus half at square. Now displacement in x direction will be equals to, what is our initial velocity in x direction? U cos theta. So this will be u cos theta into t, and acceleration in x direction again 0, so this term will become 0. So this is our displacement in x direction at any time t. For example, if our body is here, so let's suppose this is our coordinate x comma y, this is our 0 comma 0. So what will the value of x? X will be equals to u cos theta t. T is the time taken by the body from origin to this point x comma y. So this was our study in x direction. Now let's study everything in y direction as well. So let's do it here. So velocity, final velocity in y direction is equals to initial velocity in y direction plus acceleration in y direction into t. V is equals to u plus at, again formula from motion in a straight line. So final velocity in y direction, initial velocity in y direction is u sin theta. So u sin theta, acceleration is y direction is minus g into t. So this is our final velocity at any time t. This is our final velocity at any time t. Similarly, we can calculate sy, displacement in y direction at any time t. Correct? So displacement in y direction at any time t will be equals to uy t plus half a by t square. So sy is equals to ui is u sin theta into t minus half g t square. So this is the displacement in y direction at any time t, that is our value y. So this is also equals to y. Understood? So this is the process how we are supposed to study projectile motion. Now we have some important results as well from this. Let's see all those results. Now we study about the time period of projectile and time to reach the maximum height. So first let's see time to reach maximum height, h max. What is h max? If you will see our projectile this, so this is our maximum height. This is the maximum height our projectile is reaching. So this length is known as h max. Understood? So this entire length is h max, and this length from initial position to final position, this is known as range. This is known as range denoted by capital R. So how much time a projectile will take from initial position to reach at the maximum height? So that time period, let's try to calculate. How we can calculate? So if it is reaching at h max, means velocity in y direction will become 0. If you will observe here, see, x direction velocity not changing. Now if you are studying about y direction, in y direction it is like we are throwing a particle upward, we are giving some velocity u sin theta to a particle in the upward direction. What will happen? It will reach at the maximum height and then it will stop, and then it will come back. Means it is stopping at maximum height. Means velocity in y direction at maximum height will be equals to 0. Means this velocity will become 0 at maximum height. So Vy is equals to 0 at h max. Implies u sin theta is equals to gt and t is equals to u sin theta by g. So this is the time to reach maximum height. Now what will be the time period of projectile from initial position to the final position is known as time period of projectile. How we will calculate the time period of projectile? So finally what will happen? The final velocity will become opposite. If you are throwing the object vertically upward, what will happen? If you are giving the velocity v, it will come back at the same point with the same velocity v, but in the opposite direction. Means final velocity will be u sin theta, but in a negative direction. So Vy is equals to minus u sin theta. So let's put minus 2 sin theta in this formula, so it will become minus u sin theta is equals to u sin theta minus gt on the other side. So gt will be equals to 2u sin theta, or time period denoted by capital T is equals to 2u sin theta by G. So this is our time period of projectile. Understood? So these are some important formulas. If you want, you can remember. This will help us in our question. Now another thing, they may ask you about the H max. What will be the maximum height? What will be this maximum height or this range of our projectile? How we will calculate that? Again, for maximum height, time taken will be this much, and this Sy, displacement in y direction, is H max. So for maximum height, for H max, what we will do, we'll use this formula, displacement in y direction. So Sy is equals to H max. So instead of Sy, I am writing H max is equals to u sin theta. And what will be the time taken by a projectile to reach maximum height? We already calculate u sin theta. So this will be u sin theta by g, u sin theta by g, minus half g t square. Again t will put u sin theta by g, so square will be u square sin square theta by g. Now see, u square sin square by g, and this is g square, correct? So this one g and g will cancel out. So u square sin square theta by g, u square sin square theta by g. See, u square sin square theta by g minus half u square sin square theta by g will become half u square sin square theta by g. So our H max formula will become u square sin square theta by 2g. So this is the formula for H max. Now how we will calculate range? Displacement, it means total displacement in y direction, in x direction. So range is the displacement in x direction. What is the formula for displacement in x direction? It is x is equals to u cos theta into t, and displacement, total range, means what is the displacement in x direction? R. And what will be the time? Time will be total time taken for a projectile. So in this formula, instead of Sx, we will write R. In this formula, displacement in x direction is now equals to range. So this will be equals to R is equals to u cos theta, and time. To complete the entire range, what will be the time taken? Time taken will be the time period of projectile. So instead of t, we will write 2u sin theta by g. So into 2u sin theta by g. So this is equals to u into u will become u square 2 sin theta cos theta by g, or if you will see 2 sin theta cos theta. This is the perfect formula for sin 2 theta. So this will become u square sin 2 theta by g. This is our formula for range. So these are some few important formula for our projectile motion. So if now simple questions you can solve. If they are asking time period, you can use this formula. If they are asking range, H max, this kind of simple formulas you can simply do by using this formulas. Now let's see some good questions which they have asked already in our previous year. So let's start with our first question. A projectile is fired from the surface of the earth with a velocity of 5 meters per second. So this is earth. A projectile is fired at 5 meters per second at an angle theta. Let's suppose this angle is theta with the horizontal. Another projectile fired from another planet with a velocity of 3 meters per second at the same angle follows a trajectory which is identical with the trajectory of the projectile fired on the earth. Means now we are on the another planet. This is another planet, and same projectile we are giving velocity of 3 meters per second at the same angle, and trajectory is also same. Means this parabola will also be the same parabola. Means these two parabolas are exactly equal. If they are exactly equal, means their H max will be same and their range will be same, and their range will also be same. or basically their equation of trajectory will be same. Now what is this equation of trajectory? Equation of trajectory, to find the equation of trajectory, let's see this thing first. What is our displacement in x direction? This is our displacement in x direction and this is our displacement in y direction. So x is equals to, displacement in x direction is equals to u cos theta into t, and displacement in y direction at any time t is equals to u sin theta t, minus half g t square. Correct? Now we can find the equation of trajectory as well from this. How we will find? We will calculate t from here and we'll put t in this equation. So t is equals to x divided by u cos theta. It means y is equals to u sin theta into x divided by u cos theta minus half g t square, means x square by u square cos square theta. So now equation of trajectory, y is equals to, see, u and u will get cancel out, sin theta by cos theta will become tan theta into x minus g x square divided by 2u square cos square theta. So this is known as equation of trajectory. This is known as equation of trajectory. Correct? Now if these two parabolas are exactly same, means this both, at both the planets the equation of trajectory will be same. So let's write equation of trajectory on both the planets. So for Earth, so let's write for Earth, it will be y is equals to, theta is angle is again theta, so tan theta, x minus g is the gravitational acceleration on Earth, so let's take it as GE, correct, into x square divided by 2. Velocity on Earth is 5, so 5 square cos square theta. Now trajectory on another planet y will also be same, so we should get the same equation again. So let's write the equation for this as well. Again it will be tan theta x minus g, this time gravitational acceleration at another planet, so let's donate it by g p into x square divided by 2. Velocity on the other planet is 3, so this will be 3 square cos square theta. Now if these two equation of trajectory are same, how they will be same? See, y is equals to y, tan theta x same, so this two terms should also be same, means GE x square divided by 2 times 5 square cos square theta should be equals to GP x square divided by 2 times 3 square cos square theta. Cos square theta cancel, x square cancel, 2 and 2 will get cancelled. So gravitational acceleration at P will be equals to 3 square by 25, means 9 by 25 into gravitational acceleration at Earth, which is equals to 9 into 9.8 divided by 25. Now how we will calculate this without calculator there? So what we will do, if you are seeing something like 25, simply you multiply by 4 and divided by 4. Now this will become 100. So dividing by 100 is easier than dividing by 25. So let's calculate. So this will be equals to 9 into 9 into 4 will become 36. 36 into 9.8 divided by 100. So let's do multiplication. 36 into 9.8. 8 6 are 48. 8 3 are 24. Plus 4 will become 28. 0. 9 6 are 54. 9 3 are 27. Plus 5 will be equals to 32. So this will 8, 12, 5 and 3. And there is one decimal as well, so 1 point. So this is equals to 352.8 divided by 100 is equals to 3.528. Any option we have close to 3.528? Any option? Yes, we have option A. So option A is our correct answer. Now let's see another question and let's try to solve it with the easiest method possible. So a projectile is fired at an angle of 45 degrees. So Let's make a projectile. So it has been fired at an angle of 45 degree. With the horizontal, the elevation angle of the projectile at the highest point as seen from the point on the point of the projection. So this is our point of projection and this is the highest point. What is angle of elevation? Angle of elevation is directly connect these 2 points. What will be this angle theta? This theta angle will be our angle of elevation. And this angle, projectile angle is different and angle of elevation will be different. So let's calculate that. How will we calculate that? To calculate this theta, we need this length and this length. That is, we need h max and we need r by 2, which is range by 2. So what is formula for h max? H max is equals to u square cos square u square sin square theta by 2g. This is our formula for h max, and theta is equals to 45 degrees. So this will become u square sin 45, which is 1 by root 2, and 1 by root 2 whole square will become 1 by 2. So this is equals to u square by 4g. So this is our h max. Now we need range. So formula for range, if you know, it is u square sin 2 theta by g, and theta is equals to 45. So this will become u square sin 90 degree by g, and sin 90 is 1. So this will become simply u square by g. Now tan theta. See this theta and this, so let's suppose this angle not theta, let's make it as alpha angle. Let's suppose angle of elevation is alpha. So tan alpha in this triangle, opposite upon adjacent, which is h max divided by r by 2, h max divided by r by 2. So this 2 will multiply above, so this will become 2 times h max divided by r. So tan theta, tan alpha is equals to, what is h max? U square by 4g, u square by 4g, and multiplied by 2. And what is r? U square by g. So divided by u square divided by g. So this g, u square cancel out. 2 1s are and 2 2s are, means tan theta, tan alpha is equals to 1 by 2. Alpha is equals to tan inverse 1 by 2. Any option we have tan inverse 1 by 2? Option C is our correct option. Now let's see another question. The horizontal range and the maximum height of the projectile are equal. The angle of projection of the projectile is. Now what they are telling? There is a projectile, correct? And horizontal range and maximum height of the projectile are equal, means this h max is equals to r. Horizontal range or horizontal range and maximum height of the projectile are equal, means h max is equals to r. What is the formula for h max? It is u square sin square theta, u square sin square theta by 2g, and formula for range is u square sin 2 theta by g. So g, u square cancelled out. So sin square theta by 2 is equals to, sin 2 theta is 2 sin theta cos theta, correct? So theta and sin theta will get cancel out. Sin theta cancel out, means sin theta, this 2 will multiply there, is equals to 4 times sin theta is equals to 4 times cos theta, or tan theta is equals to 4, or theta is equals to tan inverse of 4. Any option can we see? Theta is equals to tan inverse of 4. Yes, here we have B option is the correct option. I will be back soon. Till then, keep practicing. This is Anmol Yadav from Sri Gurukula signing off.